Hopefully you're convinced that configuration is great and agree that it's pretty easy to begin using the techniques we've seen so far. You're probably ready for something even cooler. In this module, we will learn about the options pattern and how it complements and extends the configuration feature in ASP.NET Core. We'll refactor the sample application to apply the options pattern by binding our configuration to options classes. This will support the injection and consumption of strongly typed options, wherever they are needed, using the Microsoft Dependency Injection container. We'll learn about and compare the three available generic options interfaces: iOptions of T, iOptions Snapshot of T, and iOptions Monitor of T. We'll look at advanced features such as using named options for common configuration definitions. And we'll apply options validation to ensure that the bound configuration meets our business rules and is sufficient for our application to function. We'll conclude by ensuring that we can easily unit test code where we depend upon these options classes. In this demo, I'll introduce the options pattern in ASP.NET Core, and we'll apply it in the tennis booking web application. The options pattern supports the binding of values from configuration onto strongly typed classes. Your first impression may be that this sounds similar to the configuration binding we looked at in the previous module. In some respects it is, but the options pattern provides other features and benefits beyond simple binding. The first significant difference is that once configured, the strongly typed options class can be injected via dependency injection. Before proceeding with this module, we should re-enable weather forecasting in our development environment by setting the configuration value to true in the appsettings.development.json file. We've been working with configuration on the index page and will continue to do so as we refactor towards using the options pattern. So far, we have consumed configuration via the injected iConfiguration dependency. Our index model only uses configuration values from a subsection of the complete configuration. It would be nice if we could encapsulate those values so that it only depends on the entries required for its functionality. We'll begin by adding a new public class called HomePageConfiguration to the project. We'll use this to represent the strongly typed options for the homepage. To save time, I'll copy the properties from the existing features class that we created in the previous module. I can then paste the properties into the HomePageConfiguration class. To be compatible with the options feature, this class must be non-abstract and have a public parameterless constructor. Each of its properties that will be bound from configuration must have a public setter. When configuration binding occurs, properties in this options class will be set from configuration entries with a matching name. A benefit of the options pattern is that we define classes representing related properties for configuring specific parts of the application. We can then apply the single responsibility principle and ensure that we create separate classes for each related group of settings as necessary. At this point, we've created a typed options class and we're ready to consume it. Consuming types can depend on specific typed options classes, containing the bound configuration values that they require. We'll do that right now inside the index model. In its constructor, we'll replace the iConfiguration parameter, accepting instead an iOptions parameter. Depending on iOptions here requires a using directive for Microsoft.extensions.options, which Visual Studio adds for me. iOptions is a generic interface and we must therefore provide a tOptions type. We'll specify the home page configuration type which we've just defined. When the MVC framework activates this page model, the required iOptions instance will be injected from the dependency injection container. We'll rename this parameter as options. We no longer need a private field to hold an iConfiguration instance. We'll replace this with a field that stores the home page configuration and name it accordingly. To assign a value, we access the options instance. The iOptions interface exposes a value property through which we can access an instance of the bound options class. We'll access that property to assign a value to the home page config field. We can now finish refactoring this class. We no longer need to bind configuration manually to a features class, so we will delete these 2 lines of code. We'll paste the homepage config field name where the local features variable was previously used. We no longer need our private features class here, and so we can delete that. Now that the code compiles, we'll run the application to verify that everything still works as expected. The application loads, but the homepage is not rendering as it was before. The weather forecast and greeting seem to be missing. The reason for this is that whilst we've added an options class and consumed it in the index model, we've not yet configured and bound the options. The properties on the options class are therefore using their default values. And this is a critical point. Failing to configure options won't necessarily result in compiler errors, and it may not even trigger runtime exceptions. Instead, it will mean that your application classes only contain the default values for each of their properties. The bulk of the options feature is defined in a package called microsoft.extensions.options. When building an ASP.NET Core application, the required packages are automatically referenced. The options package includes some extension methods to support options registration with the dependency injection container. Visiting the program file, we'll use the configure extension method to register and bind some configuration for our options class. The configure method accepts a generic argument that identifies the type to which we expect to bind our configuration. So here, we'll use the homepage configuration class. The method takes as its main argument an iConfiguration instance to bind against. We can access the configuration manager, which implements iConfiguration, from the builder and call its getSection method, just as we saw in the previous module, specifying the section name to bind from. That's all we need to do to configure our options class, so I can start the application again and see if it works correctly this time. And it does. We have successfully refactored towards the options pattern. At this point, it's fair to say there's only one real feature difference between this use of the options pattern and the configuration binding that we started with. That difference is that we can now access the options more easily wherever they are needed via dependency injection. And this can be very useful when the same configuration values are consumed from multiple parts of your application. In this demo, we'll use another options feature to support the automatic reloading of configuration when the underlying source values change. We've been using configuration from the app-settings.json file, which the JSON configuration provider loads. This provider supports change notifications, such that if the underlying app-settings.json file is modified whilst the application is running, the configuration system is aware of the new values. We'll discuss that in more detail in the module called Working with Configuration Providers. Here's the tennis booking application running in my browser. Let's first see what happens if we change the contents of the app-settings.json file whilst the application is running. We'll set the value which controls if the weather forecast is displayed on the homepage to false to disable it. Note that I'm not restarting the application, so it will continue to serve requests while I'm doing this. I'll simply save the app-settings.json file, and if I refresh the page, we can see that nothing has changed. The weather forecast is still being displayed. If I instead completely restart the application, when the homepage loads, the weather forecast is now hidden. The changes have taken effect, but only at application startup. Currently, we're accessing the options via the iOptions interface. Implementations for this interface are registered as singleton services with the dependency injection container. As a result, a single instance is created the first time it's needed, and then reused for the life of the application. Thereafter, we get the same instance each time it's injected. This means we don't see any changes to the configuration being reflected in the application until it restarts. In order to take advantage of options reloading, we need to depend on an alternative options interface called iOptions snapshot. It's a simple change to update the parameter in the constructor to accept an iOptions snapshot instead of iOptions instance. iOptions snapshot instances are registered as scoped services with the dependency injection container. This means they are created once per request, and any configuration updates from providers that support reloading are reflected in the next request. If I run the application again, the weather forecast is currently hidden when the home page loads. We'll now update the configuration to set the enable weather forecast value to true and save the file. If I refresh the page, indeed, the weather forecast is now shown, with the JSON configuration having been reloaded. The application was not restarted to achieve this live update. A degree of care must be applied when you allow configuration to be reloaded whilst an application is running. Some changes may be fairly safe, such as this example, which enables a non-critical feature on the home page. Other changes may introduce more risk, as they could change the fundamental behavior of an application. For example, changes to database connection strings may require a more controlled deployment. When applying iOptions snapshot to support reloading, consider carefully if that behavior is safe for the options class you're consuming.